Now,
Good morning, all of you. I'm Ashwani Kumar Dhingra, and I'm professor in mechanical engineering in Maharishi Dayanand University, Rohtak, Haryana, India. And I'm going to present a contributed research in this conference, which is optimization of biodiesel yield from waste cooking oil using ANNG, artificial neural network and genetic algorithm. This is the work done by my student during his PhD, and it is in the primary stage. It is a one part of the research that we have to produce the biodiesels from, you can say, the waste cooking oil. Then we can experiment that biodiesel in actual IC engines so that we can get the comparable results. So this is the initial stage of the research, which I am going to present how we maximize the yield of the biodiesel with the help of ANNGA, and we can compare with some RSM techniques how we can improve the yield of the biodiesel from the waste cooking oil. So this is the topic: optimization of biodiesel from waste cooking oil using ANNGA. Introduction: we all know biodiesel. What is biodiesel? Biodiesel is a byproduct of which we can call it first generation biodiesel biofuels, second generation biofuels, third generation biofuels. So there are three generation basically, and the first generation which can be derived from the crops. So it is very, you can say, lack of the crops, we cannot use the first generation biofuels. So irrespective of that, we are moving towards from uh, biodiesel from the waste, and waste can be of from anything. So we have used the cooking oil waste which we collected from different restaurants in our area. That waste cooking oil is the waste, and we can produce the biodiesel from the waste cooking oil, so that it will be helpful for us to make experimentation. What is the We can achieve the properties which is similar to the diesel, so that we can use in our IC engines. So it is because of the limitation of the fossil fuels, we will use biodiesels, or we can use biodiesels. And it is the process which is called transterification process, from which we can convert the, you can say, biodiesel, or we can derive the biodiesel yield from that with that process. So there are so many techniques how we maximize the yield of the biodiesel. It is a main challenge, how we increase the yield of the biodiesel, because our main focus is on yield of the biodiesel. More the yield, then we can say that fuel is efficient, and there are so many techniques which we can increase the yield of the biodiesel. So are several conventional techniques that we call response surface methodology, center composite design. But nowadays, what we are doing, that we can couple that conventional techniques to, we can say, meta heuristics or hybrid based heuristics, so that we can exactly, you can say, approximate, know what will be the yield of the biodiesel in terms of optimal parameters. There are so many parameters with the trans certification process, and we can optimize that parameters to enhance the biodiesel yields. So there are so many methods. So in this research, what we have compared with our ANNGA coupled with RSM, to the RSM, which method is better one for the biodiesel yield. These are the some simple introduction. Objectives are very simple. We have to produce the biodiesel. We have to produce from some process, and the process is simple trans certificate process. Now what is, we have to predict the yield of the waste cooking oil biodiesel using RSM, because these are the conventional techniques. We have to predict with the help of RSM yield of the biodiesel, and then we can we have established a code in MATLAB environment ANNGA, and we can also predict the different biodiesel yield from different optimized parameters, so that we can compare ANNGA with the RSM. So these are the our objective initial state. Once we can make yield higher yield of the biodiesel, Then later on we can test in IC engines so that the same similar properties we can achieve or not. Then we have materials and method. It is simple. First process is trans-certification process. It is simple. We have to use methanol. We have to use NOOH, and we have to do reactions so that we can produce biodiesels. Initially, we can heat up the waste cooking oil up to some temperature, that say 110 degrees Celsius, to remove water from that waste cooking oil, so that it can be used for the trans-certification process to produce a yield of the biodiesel. So these are the materials and method, and we have used RSM based method, CCD approach, so that we can derive number of experiments, how much experiments we can derive, and how much experiments we have to perform. So we have used RSM method, a CCD of RSM method, and it derives from MATLAB, ANN model combined with the GA toolkit. After that, that RSM technique, we got 30 experiments, and we experimented on that parameter, and after experimentation we get some results of the biodiesel yield, and that 30 experiments we are going to train with ANN in a MATLAB environment. Once we get the training to the ANN with the help of RSM solutions, then we can couple with the GA so that we can optimize the biodiesel yield with the help of GA, ANN GA. Different input parameters. So we have taken four parameters for the for we can say trans-certification process. Trans-certification process is simply for manufacturing biodiesel. So we have taken four parameters, input parameters, that is molar ratio, catalyst concentration, temperature, and time. These are the four main parameters which we use in deriving the biodiesel yield, and we have to optimize that parameters. It is the main parameter. So these are the range we have taken from various literature. These are not derived by us. These are taken from the set literature. What will be the ranges of these parameters? So after studying the literature, we have selected these ranges, and so that we can input that range into the RSM technique. So these RSM, this is the then ANN. We have used ANN in MATLAB environment. That RSM based method, we get results, 30 results as per the table, as per the four input parameters, and we can say objective function. That then we can input that parameter into ANN for we can say training of the ANN in a MATLAB environment with these parameters. So these are the parameters which we use for ANN. It is inbuilt parameters of the MATLAB. So then we have some table ANN and RSM metrics for optimization of the waste cooking oil biodiesel. That means we have compared the value obtained from the ANN and the value obtained from the RSM with the 30 experiment which we got from the CCD of RSM. So these are the four input parameters: molar, catalytic, temperature, and time. And these are the experimental yield which we performed with the help of trans-certification process. And these are the RSM predicted value which we predict with the RSM regression equation. And this is the ANN predicted value with the ANN model. So we got three values of the yield once we perform 30 experiments as per the CCT design of the RSM. So these you can see experimental yield. This portion we get from that experimental yield, biodiesel yield, which we used. Then it is RSM predicted value, and this is ANN predicted value. Our main objective is what? To maximize the yield. We have to maximize the yield. So those method which get the maximized yield is better, obviously. So these we can compare. Then these are the predicted value. Now the question is, what will be the objective of our study? So we have to optimize the process parameters of we can say trans-certification. Then we can, these predicted values of the ANN, RSM, and experimental yields. From this we can see that we can optimize the process parameter with the help of G. This is the equation of the yield of waste cooking oil which we got from the RSM. This is the equation. We have four parameters A, B, C, D. What we get, what we have the parameters, we can put in this equation, or RSM will put in this equation, and we can get the objective function, our maximization of the yield of waste cooking oil biodiesel. So response surface ANOVA, this is RSM, it is inbuilt. We have to check the our model is significant or not. So in this, significant level is in the limits. We can say our model is significant, and lack of it is non-significant. Hence the model is accurate, we can say. Regression characteristics, these are some relation, some values which we got from RSM, R square values 0.977, and adjusted R square value. That means we can predict accurately from this model. So regression plots of training and validation test of RN. This is the testing of ANN process through the graph. Our main purpose is to you can say up to 100% yield. Our main objective is nearer to 100%. We have to take 100%. So our target is what? R is 0.99, or you can near to 100, 1. So GA parameters I have taken from the MATLAB environment, because we have derived the biodiesel yield from the three methods. One is experimental, second is RSM, and third is ANN. Now we have to optimize the parameters. Optimization we can do with the help of many techniques. So I have used GA technique method for the optimization of the process parameters of the trans-certification process in order to optimize the biodiesel yield. These are the, we can say, parameters which is inbuilt in you can say MATLAB environment. So optimum range suggested by the RSM and ANNG. RSM what suggested? We have the four parameters: molar ratio, catalyst, temperature, and time. So RSM suggested these values: 6.33, 1.35, 69.8 temperature, time is 109.8, and the predicted yield is 95.37, and the experimental yield is 94.5. And ANN suggested 9, 1, 66.5, 55, 98, 98. That means what? ANN suggested near to the experimental value or more than experimental value. So we can predict the biodiesel yield from the ANNGA. We cannot do you can say experiment again and again for predicting the biodiesel. It is a time consuming process. So with the help of ANNGA, we can easily predict what will be the biodiesel yield from that process parameters if we taken, and after that we can perform experiments easily, so that we can derive the biodiesel yield in order to enable us to test in the IC engines. So it is optimum range suggested by, these are the various properties of the waste cooking biodiesels. So what we have collected the waste cooking biodiesel, we have to check the properties of that waste cooking biodiesel, what we have produced from this process, trans-certification process. So when we produce the biodiesel from the trans-certification process with the different optimum condition of the parameter, then we have sent that biodiesel to the lab for testing the various parameters, so that it is in the range of the biodiesel, so that it can be used in the IC engine easily. These are similar, we get test results. These are the parameters of the waste cooking oil which is comparable with the biodiesel. So we can use this biodiesel in IC engine easily. So conclusion, very simple. It is we have optimized different parameters. So we got the optimization of the parameters. What we got is the, we can say, molar ratio, temperature, and this you can say time and methanol to oil ratio. We got these optimal parameters of this, and due to better coefficient of determination, fewer prediction error, ANN shows superior predictive power of RSM. So when we compare ANN to the RSM, ANN provides superior results with the RSM. So we can efficiently use ANN, and if we combine ANN with the GA, then it will produce more yield with the optimized parameters. So it is the results of the ANNGA predicted the yield of waste cooking oil biodiesel 98.8%, by weight percent, and 98 weight percent at temperature 66.5, 1% by weight catalyst concentration, 55 minutes and time, and 9.1 methanol to oil molar ratio. So this is the study what we did. It is found that we can easily couple GA with the ANN in order to provide the better solutions, so that it can easily be used in the IC engines. This is my study. Thank you. If you have any question, you can ask.
Excellent, excellent.